Hi everyone, welcome to Conveyor Meetup. Today we have Andrea Battaglia who will be presenting to us. And I just want to go over a couple of reminders before I give it over to him. So the first one is if you are on an internal Red Hat list and you want to keep getting invites and just any announcements around the tools that we're developing in the community, make sure that you sign up for the Conveyor Google group. I'll put the link in the chat so you can sign up there. Because like starting in March, we'll only send out the invites to the internal Red Hat list for the first meetup of the month. Outside of that, we don't really have much. So Andrea, I'll hand it over to you.
Thanks, Jonathan, and welcome everyone. Let me turn on my video so you can see me, and let's go back to the slides. It's a pleasure to be here again, so thanks a lot, Jonathan, for inviting me. Today, this is the second of a series of webinars I'm running for the Conveyor community. And today we're going to discuss about how to design a target architecture in a digital transformation project. Of course, we focus on the workload modernization, but still it's important to have the big picture, now the complete overview of what's going on in the customer landscape in order to be able to design the target environment and make the workload modernization as smooth as possible. So I'm going to talk about myself quickly again for all the people who don't know me yet. We will go quickly through the theory, and we will use a whiteboard here to run this an interesting exercise. So I'm going to give you a kind of an overview, and we will step quickly through my mental and process and the process I recommend as a best practice to go through the architectural design. So again, welcome everyone. My name is Andrea Battaglia. I work for Red Hat. I'm a member of the EMEA partner development team. So I work with partners, enable them and support them in the business development when it's about digital transformation, edge computing, and IoT solutions and cloud native app dev. I'm bringing to you with these webinars my former experience as the technical head of Red Hat services in EMEA for digital transformation. So I was the guy going to the customer and discussing the benefits of digital transformation project, designing the target architecture and running through the proof of concept needed to start the digital transformation projects. So that's it. Let's go through the theory because it's important to give everything a context. And let me quickly recap the previous webinar. So during the webinar 1 of this webinar series, we discussed went through a few of the most risky use cases you can face when you run digital transformation projects. So we discussed how tricky it is to get rid of outdated Spring framework embedded into the application. We went through the complexity and the high risks of modernizing an application when you find an embedded cache layer within the application, so the binary, right, running in the. And we went through the difficulties and how tricky it is to get rid of handmade or homemade SDKs. As you all know, nowadays it's plenty of third-party products or interesting and excellent projects you definitely want to use rather than having something home-cooked, which is difficult to upgrade and update. So the methodology we recommend when you run digital transformation projects is mainly coupled to what we call the AMM framework, so application modernization and migration framework. The theory is important because first of all, you have to assess the existing landscape in the design phase, and we went through and we had a quick look at the tool we recommend for the assessment, for the automated assessment phase. And then you have to prove you can modernize the workload. That's why proving, while proving means you apply and rework the use case using the target technology of choice. And still, sooner or later, this proof will have to be piloted into the implemented target architecture. That's why it's very important. Even though in the framework you have a serial execution of the framework, still it's important for an architect, mainly for the architect driving and leading the digital transformation project, to have clear in mind and very, very well-designed big picture. And again, this could be tricky and cost quite a lot of resources, so don't put yourself in a rush. Of course, when you have target technology in mind, most of the stuff, initial tasks to put the final infrastructure and platform in place are immediate, so it's easy and quick. On the other hand, the riskier the project is based on the assessment based on the outcome of the assessment phase, the higher is going to be the number of customization, let's say, or configuration you have to apply to architecture itself. And don't forget that the application or the application group is supposed to run and get packaged actually in a different technology. Usually when you want to modernize your workload, you definitely want to go for container technology most of the time, and that takes quite a lot of effort actually. So we are gonna use the whiteboard shortly, but now let's consider what you can do and what you're supposed to do and you must do, in my personal opinion, during the assessment phase. We discussed already during the first webinar, the assessment phase is compulsory because thanks to the automated analysis, you can rationalize and catalog the existing application workload. And you can group them. Grouping the application means you can figure out how many of the existing applications belong to a specific category, embedded cache, Spring-based, Spring framework-based, or with tons of handmade and home-cooked stuff running inside the application. And you can pick up the proper use case. Of course, the digital transformation project impacts all the applications. But before you go through the digital transformation project, the real one, you want to definitely prove you can do the modernization. The epic is doable, proving. Keep in mind, this is a proof phase. This is not a POC. You are not POCing the target architecture saying, oh, look, this is the installation of the infrastructure. This is the platform. This is a quick start. I downloaded from the internet. This is not the way it works, right? You want definitely to pick up a use case and work on the use case, a real customer use case, and then pilot the outcome, the deliverable of the proof phase into the target architecture. So the pilot, the final pilot should be a piece of the customer workload, which works on the target architecture. That's it. And that's why we're going to use the whiteboard, and we are going to run an analysis of what we want to do and what we want to achieve. So let's go through the dashboard. Please let me know if something doesn't work, if you can't see the content of what I'm going to draw. I will be I want to show you a basic use case, but I will make sure you understand the complexity of what I'm going to draw. Usually, when you approach a digital transformation project, the standard or default landscape you find is usually composite of, and let's use different colors to give a meaning to the figures we are going to draw. Usually you have an heterogeneous environment. Customer, usually when you arrive to analyze to assess the existing, have already tried whatever emerging or cutting edge technologies like container technology, but it's just a tentative. So there is no standardization there. And we expect that most of the data center and the infrastructure under the workload is based on VMs, which is fine. VM technology is the mostly used so far, and switching to container technology is expensive in terms of resources. The learning curve is not easy, even though it's plenty of documentation out there. So it's important to have clear in mind that this is part of the even customer enablement. So the story I'm going to tell you is a story of is based on a use case I've been working on, right?
Andrea,
yeah, please.
Before you go further, can you stop sharing the slides?
Oh yes, of course.
That way we can see more of the whiteboard. Thank you.
More than happy. Sorry about that. Here we go.
There we go.
See me
Thank you.
now? Yeah, okay.
Perfect.
So this is a story from a real use case I worked on when I was young. Let's say. Just imagine this environment, right? Let's avoid taking it very, very complicated or making it probably too complex. Of course, in an old data center, you have data center replication and disaster recovery stuff. Let's stick on a singleton, right? One single data center, and just let's imagine or let's base our analysis on a single area. So what I found, thanks to the automated analysis, was a bunch of application servers. Okay, application servers based on a kind of a very outdated technology. What I figured out as well is that in between of almost each and every layer, I had this kind of integration layer. Integration is tricky because when you want to move your workload to a new platform based on a different technology, you have to take care of the way the applications you are moving, they integrate with each other. What we found as well was an interesting layer based on some standards. Now we can actually use a different figure here. Business process management. Now this is not very, very weird. Most of the technologies or the software out there implement standards. Some of them, they implement the standards better. Some of them, they don't cover the full specification, the overall specification, but still most of the stuff are there. I'm talking, of course, about the BPMN V2 specification. What was concerning me the most, okay, we've got a database here, which is pretty fine, whatever. And what was concerning me the most was a kind of, I would like you to use a different color here, but something readable. Okay, let's use the green. A cloudy area made up of hundreds of small applications that used to consume messages from the integration layer, transform the payload somehow, and just sending the, so producing another message containing the transformed payload, which was very weird. And this is actually, let's go cloud here, and let's call it transformation. So we've got application, integration, transformation, BPM, and database. So the weirdest thing was these applications or these small services here were still running on top of a Tomcat web server. They were based on Spring Boot, on Spring Framework version 3. So we're talking about an architecture which is more or less 12 to 15 years old, and consuming messages. So if you want to make or draw some connections, you have this kind of interaction here, okay? You have, of course, this interaction because you have event-driven model, which is pretty fine. Of course, the application servers and the BPM software, they were interacting with the database using some tables for persistence. This is not unusual. So far, nothing complex. The problem is the technology that needs to be created. So we have a very old version of Spring Framework. We've got lack of standard because unfortunately that specific software was not implementing all the BPM and V2 specifications. So still modernizing or moving that workload, those business processes into a new version of the specification, and of course provided by a different technology vendor was a nightmare, right? So if I want, starting from the assumptions, or given that I know what's in here, more or less, and if what am I supposed to do if I want to demonstrate to my stakeholder, to the customer, that I can go through this workload modernization? I need to pick up a use case. Please keep in mind, never choose a very, very complex or risky use case. You don't need to do that. You will go through each and every application from the customer workload, so it's not needed. That would be very, very risky. As we stated during the last webinar, you never know what you can find within the application unless you don't have a deep look into the code. So upgrading the basic framework and switching technology for deployment and packaging is not a piece of cake, right? So you have to be careful. Basic demonstration, at least this is what I did, was to demonstrate that the customer workload, and each and every business company generates 80% of its revenue from the IT. So it's perfectly fine to have application servers, right? As a target of my POC. My proof phase. So a couple of applications from the customer workload interacting with each other, hopefully working with the database, but the database is simple. You just migrate the data, and it's not that complex. Then if you want to talk about scaling or clustering on the container technology is a different topic, but that's still operational, and that's still tightly coupled to the platform administration or the software infrastructure administration. Because to me, the integration layer, BPM, and the database, they are software infrastructure, right? The real workload is the set of business processes running on the BPM tool, and of course, the application, the workload running on top of the application server in this weird transformational area. So I would like to take a couple of applications here. I would like to make them interact with each other through the integration layer. And I would like, of course, to demonstrate that they can be called from the outside world. So, for example, through HTTP protocol, which is something easy to implement, but very, very effective. So let's keep this in mind and let's go through the design of the new architecture, right? Okay, let's like it's cool. And to draw the new architecture, we don't really need any special design in mind. We want to adhere. So that's another very important recommendation I have for you. Please make sure you always stick to the standards. Don't customize anything if you don't need to, and usually you shouldn't need. So keep this always very clear in mind. So as we started with a big square, black square based on the VM technology, my idea now is to start from a platform, a Kubernetes platform. And of course, my platform of choice is Openshift, right? Not just because I work for Red Hat, but because if you try and you are happy to play with different use cases and run many tests, you will always end up with the same result. Openshift platform is far beyond any other competitor technology at the moment on the market. Okay, let's start from Openshift. Now I don't need to design, I don't need to draw even on my whiteboard different VMs, because I've got plenty of resources here. Let's imagine I've got plenty of resources. And I want to split the resources based on my needs, on the workload needs. And of course, I want to isolate the workload. So let's see from a very flexible and perspective and from a scalability standpoint, because scalability for an enterprise architect, in my humble opinion, is a must, right? So technically speaking, what I need to do is to have my namespace with two applications. And the two applications, A1 and A2, from the A area, application server, A1 and A2, they can definitely interact with an integration layer. Now, the integration layer here should be definitely based on a scalable and clusterable broker. So I would say ActiveMQ, for example. Okay. In our previous design, we had the big circle, red circle A, using and interacting with the integration layer. This is kind of important. How should I design my software architecture, right? If I consider that many applications are going to use that layer, and that layer is quite big and receives data from the outside world as well. So you have several endpoints receiving and sending out data, or let's say connected to several consumers or producers, right? Several clients. So my idea here, just starting from the basics, is to have a series of ActiveMQ pods here, okay, in a clustered mode, active possibly, AMQ, AMQ, AMQ. Why this? Because I want to be able to isolate the messages dedicated to the event-driven architecture here, and then of course make these two applications for my use case to be able to interact with the outside world, just bridging. That's why I'm talking about the technology and I'm talking about the standard. Bridging is compulsory here. So I have still my endpoints exposed to the outside world. So I'm able to have an overall event-driven environment, same kind of interaction of my workload with the third-party components that could be somewhere else. and still have a dedicated layer for the messaging interaction here. So I'm already improving the customer workload, and this basic design based on the technologies I have available on the market, technologies implementing standards, because bridging messaging bridging is a standard. I have this amazing situation where I can already scale horizontally and vertically. So depending on how I want to implement the work. This is already my basic use case. Of course, the database is going to be somewhere. So then depending on how do you want to, how much do you want to apply the microservice architecture, just keep in mind that microservices means in a microservices design, you have a dedicated data source for each and every microservice. So hopefully I'm going to have here my database that somehow is connected to the other services. And I can isolate the database or have a dedicated instance if those applications, they don't need anything else than a database. I could easily add some caching layer, but this is something we can discuss in a different webinar. Just considering I have consumed already half of my time, let's focus a bit more on the platform. We stated at the very beginning, let's discuss the entire design based on a singleton data, one single data set. Thanks to the Kubernetes and container technology, I can scale my platform, my big, huge and scalable platform through different data centers. Virtual or physical is not very important. The concept of disaster recovery is almost gone because you can make Kubernetes platform and Openshift specifically to distribute the workload independently or based on your recommendation, your configuration. So I believe that if I scale the platform and if I want to give some persistence to my containers, I need a storage solution underneath. So I definitely expect to have, as a basic here, a software-defined storage solution, which is, to me, the bare minimum. This works for a clustered database solution, for a clustered cache with some storage and persistence on the file system solution. So to me, this is the basics. Don't forget the rest of the platform. All those software-based components, but we're not talking about virtual machines or kernel or Kubernetes or Docker engine, but all those pieces of software that take care of your day one, day two automation operations. So let's consider another area here, dedicated area, because that architecture means to me even to dedicate specific amount of resources or saving parts of the components that definitely can be applied through templates as well. This is the beauty of the Kubernetes technology implemented by Openshift, actually. All these pieces of my software architecture must be actually the default. And let's use a different color. So, for example, I want to use my pipelines, up to you, whether to use Jenkins or Tecton. I want to have my container registry. I want to have my artifact repository, for example. So up to you whether to use Sonatype or any other competitor. Container registry, up to you whether to use the internal Openshift registry, or if you need to scale, just use e.io as an enterprise component. Actually guarantees the distribution of the workload. So to me, this part is definitely something you can't get rid of. and actually it should always be a basic component. The reason why I started from here, which is usually the last thing you should draw on a diagram, right, or you should add on a diagram, is because I started from the assessment phase. So if we focus on the workload, of course, we have to pick up the proper choices here. So let me just draw the interaction. And it's easy to figure out how to, keeping always in mind the latest technologies and the most stable implementation of the specification. It's easy to figure out how to go through a workload and software infrastructure scalability, and how to design the basic architecture from the automation perspective and from the platform perspective. Software defined storage to have a basic architecture which can easily be scaled based on the customer need. So let's see. Jonathan, I guess this is okay from the design perspective. Have we got any questions so far?
We don't have any questions right now, Andrea. For everyone on the call or in the meetup, go ahead and put any questions that you have in, and Andrea can tackle it as they come in. But Andrea, I think other than that, right? That kind of wraps up today's.
Well, yeah. The idea of this webinar series is to give tips and tricks. I'm happy to get challenged with any question. I'm happy to, if our audience is happy to, is keen to come back to us in the next days with some ideas or some challenges they want to submit to us. Of course, we are more than happy to have a brainstorm and a nice discussion and debate on the technologies. And this is a community, right? So Conveyor community is made up by passionate people for passionate people. So for any kind of question, for any kind of support you would actually need, reach out to Jonathan or myself directly. You have the my contact email on my slide deck, so I'm happy to help anytime.
Okay, awesome. And we actually have a couple questions that came in. So the first one is, how do you incorporate design patterns such as Saga and DQRS with respect to data consistency with microservices?
Now, usually when it's about data consistency, transactionality, or talking about messages, data retention, data consistency, it's a good practice, in my humble opinion, to delegate those parts to the software, to the software infrastructure. So actually, you don't implement an MQ server on your own. You usually pick up a product that can guarantee and implements out of the box and provides those features, right? In the microservices architecture, the microservice should be atomic. And this is part of what I usually repeat to my audience. Microservice is a buzzword, right? Services should be atomic, should be dedicated to a specific feature, and should not reinvent or re-implement the wheel. So that's something, data consistency, and should be dedicated to database and to the storage, if we talk about, of course, data stored in a database. And the same is for the caching, right? If I want to put something like a cache layer here, now, this is visible. A cache layer here. So applications are not supposed to query the database all the time. And I want to replicate this in an active way, so having this platform scaled on different virtual data centers from the infrastructure perspective. I want this cache to implement data consistency internally. I'm expecting this to work independently from my services, right? So if my services, they perform CRUD operation on the cache here or on the database, what the application should look like, so what my workload should take care of is that the transaction ends correctly. Data synchronization, whether it's based on replication or distribution, is not something the workload should care about, the customer workload. So this is business logic. The rest is software infrastructure. I hope I gave an answer to our. Okay.
Yeah. So the next question is, where does the BPM from the original application fit into this new architecture?
Yeah, the interaction is very poor here using this. Oh, one light is gone. Sorry, I can see my shadow here. Into this architecture, so BPM, as we stated before, the real business logic in a BPM environment, so in a BPM system, is made up of the business processes. Okay, so you just need to re-implement the business processes, and of course you want the BPM. And the reason why I didn't put it here is simply because I'm just discussing a basic architecture, right? Oh, by the way, don't forget the proof phase is important for you to demonstrate your skills and capability in the workload modernization, but it's compulsory, in my humble opinion, to demonstrate to your customer that the choices you have made, so the technology you are picking up, is the proper one to have to close the project successfully. Of course, the BPM, in my opinion, is definitely something that goes completely separated from the rest. From the rest of the software infrastructure and workload. So I expect my BPM here. My BPM is clustered and independent and can scale automatically. Then, of course, thanks to the BPM specification, you can trigger your business processes using events or just using timers and whatever, but that should be completely independent. And still, the interaction between the big integration layer here and the BPM cluster can definitely be scaled. So you see, I'm not reinventing the wheel. This is blue, so you have the bridge here, okay? And still I'm kind of creating a template or some standards to apply my architectural design.
John, let us know whether that answered your question. In the meantime, we'll go on to the next one. So the next question, Andrea, is, speaking of microservices being atomic, how do you work with customers to draw the line on how much to implement within a service? Do you have a rule of thumb for endpoints within a specific service or functionality?
Well, no. No, it depends on the workload and the use case. So if a customer comes to you with a few hundreds of monolithic applications, that of course, so I've been watching and attending to the other Conveyor events. There are lots of discussion and lots of tools you can use to split monolithic applications into microservices. What it matters is that you are capable of discussing with the stakeholders the limits, because the limits are depend on business logic. So I can't draw any limit, right? Limits depend on the business logic. Now, as you know, Jonathan, I'm running a community called Quarkus and IoT community. And we are POCing several stuff. The current use case is based on the air quality measurement based on Raspberry Pis and having Quarkus running on the Raspberry Pi. So if you imagine, now let me give you this use case. If you imagine a measurement station that starts for the first time, whatever kind of IoT device, starting up for booting for the first time, the only information it has embedded is the link, the URL of the data center. So the device has to register first, and then we'll get back, if the registration is successful and the device hasn't been hacked, for example, the device will get back a certificate that is supposed to be used to connect to the MQTT endpoint to start sending the telemetry. So from the data center perspective, I wouldn't definitely put the registration, the certificate management, the station data management, and the localization management in the same service. So I've got the concept of registration. The registration service is a service that serves directly the IoT devices, but still has to connect to the database to work on to manage the weather station data. So that's what I will do actually. The registration service. Then I would have a station service that connects to the database. The registration service depends on the station service, of course, and I would use actually let's say a certificate issuer. Okay. These would take care of the provisioning of the certificates, actually. And then, last but not least, the measurement station is supposed to send me the coordinates, right? So if I want to enrich my data in order to be able to put them into a different database, which is supposed to be here, for example, let's say, time series, somehow, database. In that case, I need another service called, for example, localization service. That would query, using a REST client, OpenStreetMap reverse APIs, to give me the address-based or address, the city and the country code or the country name based on the coordinates I get in the registration service. So this is what I would actually HTTPS, and this is what the localization service would do. So localization service used by station service used by registration service, and registration service using as well cert issuer. So I've got 4 services rather than just one single monolithic application. This is why the connection, the interaction with the stakeholder is compulsory. It's very, very important. Keep this in mind. Hope I gave you a proper answer.
Thank you, Andrea. So I think that's the last of the questions. Richard, that didn't answer your question fully. Feel free to put it in the chat. And let me see. Let me make sure there's nothing else I'm missing. All right, I had something else come in. So BPM is a stateful service and integration scenario. In your case, are you running it on Openshift or standalone?
I tend to put everything on Openshift anyway. So the concept of stateful, it really depends on where, how, when you save the data. Of course, it's about sessions, and the sessions that should be considered within the application and the workload namespace as well, but still. I would consider using BPM in OpenShift, and mainly because I can use pipelines as well. Red Hat has an excellent solution for BPM, by the way. But generally speaking, talking about architectural design, I would try to not reuse the old infrastructure unless the services I'm analyzing, no, or I actually analyzed during the assessment phase are standalone services that just, for example, expose a couple of REST APIs, and they are not tightly coupled to anything else in here, right? So those services, they are not worth to be migrated or modernized to get modernized to the new environment. In that case, if it's a single application, it's fine to leave it there. And most of the time, those small applications I'm talking about, they are not modernizable, let's say. You can't touch them because you have no source code, or they are under any kind of license. So BPM should definitely stay here. A time series database as well. Cache should stay there. If they are cloud ready, if those products here, all the products I mentioned, ActiveMQ, DataGrid, or whatever, MySQL, Postgre, if they are cloud ready, or even better, cloud native, they will scale accordingly without any trouble.
Nuva, let us know whether you still need a bit more clarity on that, so that way we can direct and get to it. Yeah, so now I don't see anything else, Andrea. I did get a question kind of related more to this design that you have here. Is this anywhere in your slide deck? I think people would love to have an example of this that they can look at.
Okay. No. I love using whiteboard because that helps and promotes and accelerates interaction. But I can do something and share it with the community. Unfortunately, I'm very busy nowadays because I'm working on this kind of big event driven by the QIoT community. But still, I promise you that sooner or later I will post something. And
okay.
Don't forget,
awesome.
Let's remind the audience as well that we will run the third and the fourth of this webinar of this webinar series, respectively, in mid-March and mid-April, right, Jonathan?
Correct. So everyone, if you want to get invites to those, I did put the link to the Conveyor group at the beginning of the chat. Just go sign up there, and that way you get the invites.
We are going to go through the technical details of this stuff. So we will draw these again. And we will have some guests, hopefully, subject matter experts talking about, for example, migrating from typical to ActiveMQ, or from a standalone database to a scalable one. I could actually invite someone from my community as well, discussing time series and the way it works in a cloud native environment. So stay tuned.
Yeah. So stay tuned for that, guys. And I think with that, that's a wrap for today. Everyone, I did put the link to the survey in the chat as well. So this is a new format that we're trying. We'd be curious to hear what your thoughts and experience has been like. So Andrea, is there any closing notes as to like how people can either reach you if they have any more questions, or?
Anytime you're happy to have a debate or a discussion, reach out to me, andrea.battaglia@redhat.com. Or I guess, I don't know, Jonathan, through the Conveyor community, but I'm available on Twitter, on LinkedIn. So reach out to me anytime, happy to have. And if there is anyone who's happy to contribute and be part of the community, QIoT community, the QIoT project, please let us know. We will have the chance to have a brainstorming session, and I can definitely onboard you into the project. Thanks, Jonathan, for everything. And
thank you, Andrea. All right, guys. Well, hope you have a good rest of your day, and we'll see you next time. Ciao.